What's up, folks? So we're gonna start on the second day of just checking some stuff out with this Lincoln, this flood vehicle. I did do a video yesterday, and y'all saw everything I pretty much went through. There was a couple more things I discovered as I just start checking things. It's kind of hard when you get something like this because you don't have like a sense of direction, because it's just so overwhelmed with so many components, and every individual thing has to be tested to ensure that it's worth putting money into. So this does have a parasitic draw also, and it's some reason is pulling 500 milliamps, and I gotta discover that at some point in time too. So I need to, wherever the insurance person I talk to, I have to bring that up at some point in time during all these other findings. Real quick, the liftgate module, this is it. I wound up pulling that out because there was no communication. Luckily, there was a manual release in the door, and I was able to open it and gain access to this. I'll show you where this is located, but here's the water damage. This is likely going to be the reason why I didn't have any communication with the body control module. So this lost communication, and here's the reason why. Let me show you what it looked like in the back. So here's where the spare tire is. I did pull some more water out by pulling that plug there. The module resides here in the back, and you can see where the water invaded this space, and looked like it got up to about right here, and submerging that unit. So you can get a better angle. That unit sits right here in the back. That's where it sits right there, held in by some quick disconnect tabs. The motor itself, the actuator, I think this is going to be fine, but this has seen some moisture and begin to rust. So for tonight, we're just going to check the driver window, because I assume whatever happened to this driver window happened to all the windows, and just do one thing at a time. So this is a very simple system. For the most part, it's not the conventional rudimentary old style system. This does have constant power and grounds. We're going to check those, and then it has a relay of some sort inside of here that takes a small amount of current and performs a duty, which pretty much comprises of 12 volt inputs, depending on if you go up or down or not, and depending on if it's auto up or auto down, it's going to supply 12 volt and ground on the auto side. So I can tell you, reading the wiring diagram, obviously we're going to have black, ground, red. That's going to be our constant 12 volt, and this green and violet wire here is going to be also a 12 volt supply, so we'll check that. And then our other three wires, four wires are going to be either the 12 volt supply and then auto up, auto down. So we'll check those and see if we just got some basic signals. But I can tell you, I mean, we likely going to have some adequate signals because it works. You can hear it trying to work. So it's trying to do something inside of there, and it's just not doing anything. We can pull this down and then inspect the side of the motor and see if the window can move up and down, and if the motor actually operates when it's freestanding and doesn't have the window resistance. All right, folks, so here we are. We're at the driver's side door. I do have the window switch taken out, and mind you, like I was telling you, the motor makes noise. You can hear the noise like it's trying to work, but like I said, I have a hard time believing that all of them are bad. And the main thing I would want to check, obviously, is going to be powers and grounds, and load supported. Yesterday we wound up load supported, and it worked just fine. So, but let's take a better look at it and see what's going on. So here our red wire is going to be our power supply. We have adequate voltage there. The, what is this? The green and violet. We have 12 volts there, maximum of 12.45. And then our ground, which isn't making any noise, but it has a maximum voltage of 0.88 volts, and a ground should be below 300 millivolts. So like this one is a perfect ground. Let me turn the sound off for you. So with the ground here, this is a perfect ground. We're around 0.63. Oh, I wound up pulling the max there. There we go. I guess because I'm moving it, it's causing some inconsistency. So yeah, if I wave it on the tip, it's going to cause some inconsistencies. But this is a perfect ground here. It's less than 300 millivolts, 0.02. We got 1.14 volts, 1.13, and I could try cleaning this off, but let me take this out. Maybe I want to try to get a good ground and see what happens. But we can load support our circuit, and it works fine and strong. Like, it'll support a whole, oh gosh, it'll support a whole high beam light. And that's why I'm kind of like, do I worry about it or do I not worry about it? Let's get this right here. It'll support this. That's a whole test light. I mean, a whole high beam. It's like, I guess, I mean, I don't know how many amps a window motor uses, but I mean, it is pretty, I'm pretty sure it's loaded up more than a high beam. But I'm not going to worry about that ground. Let's take, the component out, because we know we have some sort of operation. The relay inside the window motor's trying to operate. Let's see what our window motor looks like. Now. Yeah. So the window should go up and down. There we go. So yeah, the window works. Bound up a little bit for a second, but it goes up and down. Oh wow, the motor literally, wow. What the hell did that have to do with the motor working? That's wow. So now it wants to work. I'm confused. What does this have to do with this? So I mean, technically I was right. The window motor is bad. Now I probably need to calibrate the damn thing. Let's put it back in there. See if it'll work now. It's not going to work appropriately because I turned it and it's going to be out of calibration. So just like the fan motors, they just need to be worked a little bit, stretched out, and then they came back to life. See what happens now. Oh wow, yeah, it works now. Yeah, it just needs to be calibrated. Let me hold it. Go back down. Let's see what happens. Yeah, I just need to calibrate it. There's a special procedure you got to go through. I did find that out, but the motor works. I'm pretty sure all of them just need to be stretched out, and yeah, I guess a good thing that they don't have to replace it. All right, it's the next day. I got a little overwhelmed and was over checking the stuff that I did check because I had other things I had to do. So we're in the back in the hatch trunk on the left side rear. So we're going to check really quick powers, grounds, and CAN for our lift gate tailgate module. And simple powers and grounds and CAN, that's it. So I did pre-mark out my areas where my powers are going to be. We got the black here, it should be number 1. The red and white, well, the black is going to be ground, number 1. 4 red and white, positive, and 9, this is red here, it should be positive also. So we're going to listen for some voltage and audible sound. So we got good ground, perfect ground actually. That's number 1. Battery voltage, perfect. That's on number 4. And number 9, perfect voltage there. So we got battery voltage, 2 sources, and ground. CAN low and CAN high. We got 2.49 the low. That should be CAN low. No, this is CAN low. So this is CAN low, averaging 2.40, and CAN high is averaging 2.6. About 2.7. So 2.6, 2.7. They all supposed to be around about 2.5 anyway. So CAN low and CAN high are in good shape. Pretty much just need a gateway module. We saw was saturated in water. So let's move on to something else. So one of the things I diagnosed that was not working was the exterior side mirrors. It was no functionality. Luckily for this issue, it pointed me in a direction of resolving another problem, and I'll explain that shortly. But what was happening, I went to powers and grounds. So I had adequate ground. I didn't have power on this white and red wire. I pulled the wiring diagram. I got to inspecting this. Right at our body control module on fuse number 7, not only does it send power to our exterior rear view mirror switch, which was inadequate of a 12-volt source, but it also distributes power to our driver seat module. So that restored power to that, and it also generated power to our left power seat switch, and it restored power to that also. So the side mirrors work. The seat makes noise and attempt to move, but it don't work going back and forth because it's rusted out. However, the lumbar part works. You can see that moving in. You can see that this works, but so the seat needs to be replaced. Now, mind you, I haven't quite figured this out yet. There was a parasitic draw, and I'm hoping, being that the body control module happened to get submerged, the body control module is going to have to be replaced too. But here's the blown fuse right there. Yeah, this was the blown fuse. that I found on fuse link 7 under the bottom there. So we know we need the liftgate module because that's just sabotage. We got the windows working unintentionally, but that's a good thing because of the motor. Side mirrors got back working again because we restored power there, and the seats power got restored working. The blower motor, let's check that real quick, but before I do, let me show you where I'm questioning the body control module since we're on this side. So I am going to do another parasitic draw test, but that odd looking fuse up here, that one up there, the red one, that's the one I had wound up replacing. It's a bladed fuse versus a small mini, whatever they call these fuses I showed you. But you can see that there's corrosion around all the points on those fusible links. Not sure well it picks that up, but you can see that white soot. And if that's the case, if I continue to have this parasitic draw, I'm going to go ahead and replace this just out of just being cautious. And again, I think this is what's probably causing my parasitic draw, because this did get submerged in the water also. Because mind you, the water went, you can see right where the pedal is at the top. If it got up here, then it partially submerged this body control module, at least the bottom half here, and then moisture will get up there and rise up and cause some bridging of the contacts and a lot of issues. So I'll come back to this last, but let's check out the blower motor. Look at all that rust formating. Look at all that rust forming. It's all on the brackets, intermediate shaft, and some of the brackets here. So I think this can be fixed, but it's just not looking good. So let's just check the seat out really quick. I am hooked up on the motor here. This should be the motor that allows it to go back and forward. And I'm just gonna hook up on a power wire. Just ignore the noise for a little bit, but I wanna change the state of this. And it's administering power, and it's got good grounds, and that's what it do, just reverses the polarity, and it's not moving. So the seat's gonna have to be replaced. So I know we're gonna need 2 seats. Is that mold starting right there? Oh gosh. All right, let's check this one last component, because we know the blower motor needs to be replaced. We know I was able to get it to work by jumping the wire. The compressor came on. So I was able to get the blower motor to work. Y'all saw that, but I could probably demonstrate it now, but that's irrelevant. If you looked at the last video, you would know. I'm on this red wire here in the back. Is it red? I want to say, yeah, this red wire, the small red wire here. And the way this works, likely it's probably going to generate some sort of variable resistance or some pulse width modulated signal to that resistor, I'm assuming. But what I'm looking for is some sort of change in potential, whether I go up or down with the blower motor. Well, let's turn that on, because right now I got the speed on high. We're at 10.6. I'm going to sweep this low. Let's just go all the way down to 1. We're at 0.01 volt. Let's sweep it up. I got 2 bars, 3 bars, and high. So I likely will need a scope to determine this, but my thing is, well, there's some sort of command from this to operate that thing, the blower resistor, to work that fan. So that's the main thing I need, is the capabilities of working. So this ain't sensitive enough or have the ability to monitor something rapidly changing like that. That's why we need something graphical like an oscilloscope. But being that I saw some sort of sweeping, I'm going to assume that this climate control head is fine. So I got most of this stuff checked out, I just got to check on that parasitic draw. The vehicle been sitting for 20 minutes. Make sure it goes to sleep. Now the lights are off. This light down here is off. That was part of the interior lights. The vanity light and the rear light and the hatch, that's all off. And right now we're currently making a 500 milliamp draw on the system. I need a 50 milliamp draw, so I need to move over one more decimal place to the right. And I could, this is me taking a shot in the dark, but being that the body control module was affected and part of it was submerged in there, knowing how the influence of water and the minerals in the water and how that could cause issues with computer systems. I mean, I'm hoping that one, either when I replace everything that needs to be replaced, the draw goes away. And that's hope. Secondly, you know, if we replace the body control module and I just happen to get lucky and replace that, because it needs to be replaced anyway, technically, because of the water damage that it sustained. So we can see that it's been compromised. Will it fix this? I don't know, but it needs to be replaced anyway. So this will be me shooting apart at this vehicle. For the most part, for all the other stuff, I can recommend the motors and stuff be replaced, even the fan assembly, all that stuff be replaced. But it's like, if I can get them to work, and could probably just, you know, check it off as a win. And if the customer's on the same page, ride it out and let it go and see what happens in the future. Because it seemed like the fans are working fine, the car's idling fine. In the first video, it didn't want to idle right. You saw that misfire, so it wasn't right. But it did clear a lot, cleared up on its own, engine-wise, functionality, and fans. And you see the pattern. Move some stuff started working. Do you replace it or leave it alone? So this is not my vehicle. If it was mine, I would honestly, like, if I could move it, get, like, I got the window to work and the fans to work, leave it alone, because if I need to replace it in the future, hell, I can. But the problem is it's not my car. So that's why I have to exercise my abilities to relay this information to the customer, see what he wants to do. And I don't want to have to interact with this insurance company or whatever in regards to what the vehicle may need, because we know this could potentially be paradoxical in the future if issues start to really manifest down the line. So the main thing is get everything replaced quickly, get the water out as fast as possible, and hope that everything is capable of airing out on its own. So we got quite a bit done today. I'm good enough to where I can just give a nice estimate for a lot of stuff that needs to be replaced and see what happens. Especially if we can get this done quick enough and get this mold out before it starts to spread. Well, I'm gonna let this ride out. If I get it, then we'll go through the replacement of the parts here and there, see what happens. But if anything happened, I'll definitely update. I really like everybody's perspective on what will happen if they were in this situation. Would you have went through the extent of testing this stuff? Would you just replace things? It's pretty interesting. Some people, will be like, leave it alone. It's a lost cause. Some people are going to be like, you know what, let's go ahead and fix it. I don't know. I like people's feedback. But if anything happened, I'll definitely update. Hit that link, subscribe to the channel, stay informed, how to reach my work. See you next one.